Okay, when adding rational expressions, again, it's very, very similar to how you would add regular fractions. So, for example, if you had to add, now we're going to continue with this here in a moment, but say you had to add just like, say, 2/3 plus 1/3. Well, we know when the denominators are the same, that gives you permission to add or subtract the numerators, which leaves you with 2 plus 1 over 3. That is the only time you get the permission slip, when the denominators are the same. Well, the same thing is true for rational expressions. The pattern is simple. Are the denominators the same? Yes or no? And it turns out that both denominators are v squared minus 4v minus 12. Since the denominators are the same, it gives us permission to add and subtract the numerators, add or subtract numerators, in this case subtracting, so the denominator definitely will be 4 squared minus 4v minus 12, and then we'll have v minus 1 minus the quantity v plus 2. When we distribute this negative, there's two ways to put this. You can say the opposite of both terms. You could say change it to addition and then make this -1 and multiply -1 by each of the terms. There's a number of different ways you could look at it. If you covered this, you would look at it as the opposite of v plus the opposite of 2. If you put a 1 in front of here, you could think of it as distribution. So -1 times 1v, -1 times 2. But ultimately you end up with v minus 1 minus v minus 2 all over v squared minus 4v minus 12. And then these v's add to 0 because we basically have a positive v here and a negative v, and your result is -3, -1 plus -2 over v squared minus 4v minus 12. And that's your result. So how we do problems with rational expressions is the same way we'd do them as if we had integers in the denominator, because variables represent numbers.